The 68, 95, and 99.7 rule.
So for a normal distribution, approximately 68% of the observations lie within one standard deviation of the mean, 95% lie within two standard deviations, and 99.7% lie within three standard deviations. So this is what the graph looks like, which we'll need to use to help solve a lot of our questions. So how can we actually read this graph? Well, the middle value here is representing the mean. The area under the graph represents the percentage of observations that lie within that standard deviation. So as you can see here, the yellow space represents one standard deviation, blue representing two standard deviations, and the purple representing three standard deviations. So this is the graph that I used in my bound reference to help me quickly calculate the area under the graph for certain percentages and standard deviations. Now let's apply this to a question. This question tells us that the mean is 25 minutes and a standard deviation of 5 minutes for the delivery time of pizzas. And question A is asking us what percentage has the delivery time between 15 and 35 minutes. So we can use this and apply it to the graph. We know that the mean here would be 25 and one standard deviation is 5. We get 30, 35, 40, and 45, and 5, 10, 15, and 20 on this side here. So for here, you can see that we did the mean minus one standard deviation, minus two standard deviations, and minus 3, and vice versa for the right side here. So now that we've got all our numbers, we can see what lies between 15 and 35. 15 and 35 is around here, so that would be two standard deviations. And how much percent lies within two standard deviations of the mean? 95%. Now the second question is asking us what percentage of delivery time is greater than 30 minutes. First, we need to see how many standard deviations is 30 minutes. Here we can see that it's one standard deviation. And we need to calculate how much percent lies greater than this value. We can do that by adding together 13.5, 2.35, and 0.15, which brings us to 16%. The last question is asking us, if we have 2,000 pizzas delivered in 1 month, how many of these pizzas were delivered in less than 10 minutes? It is 3 standard deviations away from the mean, and anything less than that is what we're looking for, which is how we get 0.15%. Now we need to do 0.5 over 100, representing percentage, times 2,000 pizzas, which is how we get 3 pizzas that were delivered in less than 10 minutes. Now, a very common mistake here is mixing up 0.15 times 2,000 rather than 0.15 over 100 times 2,000. And this would get us to 300 pizzas rather than 3, as a lot of people tend to forget that 0.15 would represent 15% rather than 0.15%.